All right, so we're going to finish up 6.1. This is part 2. All right, so let's read through this problem. We're going to grab what we need, and then we're going to go ahead and use StatCrunch rather than the long way that's on the right here, doing it by hand. So we've got a college admissions director wishes to estimate the mean age of all students currently enrolled. In a random sample of 20 students, so random sample of 20 students, that means that n is equal to 20, right? That's our sample size. The mean age is found to be 22.9 years. So that is my sample mean. From past studies, the standard deviation is known to be 1.5 years. And so we're going to make the assumption that that is our population standard deviation, and that is 1.5. Put a point in there. Okay, they do tell us that the population is normally distributed. We needed to see that because the problem is the sample size is less than 30. And so we needed to see that the population is normally distributed. And then finally, they told us they want a 90% confidence interval. So that means that our confidence level C is going to be 0.90. All right, so I think we have everything we need from the problem. We are not going to worry about doing this by hand. We're going to come over here and we're going to go into StatCrunch. We're going to hit ZStat, one sample with summary. Okay, this is on your resource sheet as well. And we're going to put in what we know. So first we're going to put in the sample mean. That's 22.9. Notice this does not say the sample standard deviation. This is actually the population standard deviation. So we're going to put 1.5 in. StatCrunch is going to take care of adjusting that for us. The sample size, we know our sample size is 20. We have 20 students. And then we're going to come down here and click on confidence interval and go ahead and put 0.90 in because that's the confidence level we want. We want the 90%. Then we hit compute and the computer is going to do it for us. It gives us our lower limit, and our upper limit. So we have 22.3 is our lower bound of our confidence interval, and 23.5 is the upper bound. Now we are going to use StatCrunch for the confidence interval, but if we are asked to find a minimum sample size that's needed, we're going to have to use our formula. And you'll see on your resource sheet that next to this formula for minimum sample size, it's going to say calculator. With finding the sample size, we're going to always round up to the next whole number. We'll talk about that as we go on, but it does not matter what we get. So let me see. If I had 15.1, I'm still going to round up to 16. And that's because otherwise I'm going to have an issue that I might not include everything that I need. I want that sample size to for sure be big enough. And so if I go barely past 15, I've got to head up to 16, even though that's not usually how we round. But you'll see that as we go along with the problems. All right, so let's try this one. The researcher in example 1 wants to estimate the mean number of hours spent on required athletic activities by all student athletes in the conference. So this is what one of the problems we did in part 1. It says how many student athletes must be included in the sample to be 95% confident that the sample mean is within 0.5 hour of the population mean. Okay, a lot going on. Let's go back to the original problem. So the original problem told us that the standard deviation was 2.3. We want a 95% confidence level. And so therefore our Z of C, if you go to your resource sheet and look at 95%, you'll see that the Z is 1.96. Okay, also, if you look at your formula here, we also need an E. So if you see this wording that says that you're confident that the sample mean is within 0.5 hours, that is your E. Okay, that is your margin of error, 0.5. They're not always going to literally say the margin of error is. Mostly they're going to say that they're confident that the sample mean is within a certain amount, and that's going to be our E. So at this point, we can put this in our calculator. So we need, on top, we need 1.96, and then we're going to multiply that times our standard deviation, which is 2.3. We're going to divide all of that by E, which is 0.5, and then we have to remember to square that. Okay, so you definitely want to use parentheses so that you'll get that squared. Now, when we put that in our calculator, we get 81.29. Normally, we would round that down to 81, but because we're looking at sample size and we want to be positive that we've used a big enough sample size, because we're even barely past 81, we're going to go ahead and round up to 82. Okay, so for this study, if the researcher wants to be 95% confident that the sample mean is within 0.5 hours of the population mean, then we would actually need 82 students. Since the researcher only looked at 40, he would need 42 more students. All right, let's look at some homework problems. So here it says find the critical value Z of C necessary to form a confidence interval for C equals 0.82. All right, so the problem is our resource sheet only uses, they only give us 90%, 95%, and 99%, and this is asking for 82%. So we're going to go ahead and use the normal calculator. We want the area here between, because remember with confidence intervals, we want to use between. We want this between to be 0.82. Let me make that a 0.82. And so that's why I put that into this side of StatCrunch. So when I went into StatCrunch, I did calculator normal, and then I hit between. At that point, right now they didn't give me a mean or a standard deviation, so I'm going to leave the mean at 0, the standard deviation at 1, and I'm looking for Z. Notice the problem here. I'm looking for Z. I'm looking for the critical value, and so therefore I'm going to put the 0.82 on this side, hit compute, and see how it gives me negative 1.34 and positive 1.34. Now this is a little tricky, but they only want the positive number on this one because that's the critical value. The critical value is the positive one. We know that if we're using it on the number line that we would also need the negative value as well. So we're going to put that 1.34 into the answer and move to our next problem. Okay, at first glance, this looks kind of crazy, but it's actually pretty straightforward. What happens is the sampling error is going to be the sample mean minus the population mean. Okay, so it's going to be the sample mean minus the population mean. And it's on your resource sheet. Well, they give us both of those. right? Up here, they showed me that the sample mean is 4.2, so I put that right here. They showed me that the population mean is 4.71, and so I'm just going to subtract those. What I get is negative 0.51. So what I know, because this is negative, I know that the sample mean is to the left of the population mean, right? Because I got a negative number when I subtracted them. So the sample mean is below the population mean. But that's all they want. They just want the sampling error. All right, here's another problem. They gave me we want to make a confidence interval. So as soon as I see those words, confidence interval, I know that I'm going to go to ZStat. They gave me the confidence level of 98%. They gave me my sample mean, population standard deviation, and my sample size. So what I'm going to do is go to ZStat and one sample with summary, and I'm going to put in what I know. I'm going to put in the mean, which is 16.4. I'm going to put in my population standard deviation of 5.0, and I'm going to put in my sample size of 75. Then I'm going to come down here and click on the confidence interval, and I'm going to put my level, which is 0.98. At that point, I'm going to hit compute, and notice I get my lower limit and my upper limit. So what happens is I end up with 15.1 on the lower limit. That came from here, and that's the lower endpoint of my confidence interval. And then I have 17.7 on the upper end, and that came from here, and that's my upper endpoint. Okay, so there's a couple different ways we can do this problem. What I do is they actually gave me the confidence interval, and they want to know the sample mean, which is in the middle, and they also want to know the margin of error. All right, so I have a few choices of what I can do. I went ahead and drew a number line, and I put the 1.52 on the lower end, and I put the 1.94 on the upper end, because that's the definition of a confidence interval, right? The lower endpoint is 1.52, the upper endpoint is 1.94. Now, at this point, in order for me to find the mean, I can just find the average, because we know this is symmetric. We know that the mean, the sample mean, needs to be smack dab in the middle. So if I add those two endpoints together, I did that here, add the endpoints together and divide by 2, I get 1.73. That's my sample mean. And that's going to go right here in the middle. So now you can do a couple things for the margin of error. You can either see how far apart the average in the middle, the sample mean in the middle, is from the endpoint. So you could take 1.94 on the end there and subtract the mean, and that's going to give you 0.21. So you can do it that way, or you can, you know that you're going to add and subtract the margin of error. So if you want, you could subtract the two endpoints. Take the higher endpoint of 1.94 minus the lower of 1.52 and divide by 2, and that's going to also give you your margin of error. So whichever way works for you. So you try it and let me know if you have questions. Okay, let's do another sample size. So when you see that you have minimum sample size, go to your resource sheet and find your formula, because then you know what you're looking for. So your resource sheet shows the minimum sample size and it gives you the formula. So we know that we need Z of C. That's going to come from the table on your resource sheet. We know we need the population standard deviation, and we know we need the margin of error. So this problem actually gave us most of that. It gave us that C was equal to 0.95. So if you go to your resource sheet and look at the 90%, 95%, and 99%, you'll see that you have the Z of C is going to be 1.96. So Z of 0.95 is equal to 1.96. Then they gave me the standard deviation, that's 7.3, and they gave me, whoops, not N, they gave me the sample size, or excuse me, the margin of error, which is 1. Okay, so now I'm going to pop everything in. I'm going to put the Z of C goes right here, that's 1.96. My standard deviation goes here, that's 7.3. I'm going to divide by the margin of error, that's 1, and then don't forget to square. So when I do that, I get 204.7188. So remember, we're always going to round up no matter what, but this one already would naturally round up to 205. And so my minimum sample size, in order to have this 95% confidence, needs to be 205. Okay, so this problem has a lot going on. Let's look at the beginning. At the beginning, they tell me that a cheese processing company wants to estimate the mean cholesterol content of all 1 ounce servings type of cheese. This is kind of like the paint can. It's making sure, with the paint can, we were making sure that we were filling up the paint can. With this one, we want to look at the cholesterol content of a type of cheese. And the estimate must be within 0.81 milligram of the population mean. That is my E. Because that word's estimate must be within, that is going to be my margin of error. Okay, so first they want me to determine the minimum sample size to have a 95% confidence interval. All right, so with a 95% confidence interval, that means I need Z of 0.95. So go to your table on your resource sheet, and you'll see that that's 1.96. All right, what else do I need? I need the standard deviation, So the population standard deviation is right here. They gave it to me. It's 3.07. So I think I have everything I need. So I've got my Z of 95, and that is 1.96. I have my standard deviation of 3.07. I have my E of 0.81, and then don't forget to square. When I do that, I get 55.18472. Now remember, because I'm even just a smidgen past the 55, I need to round up to 56. Okay, so this is my sample size. This is the first answer. In order to be 95% confident, I have got to have a sample size of 56. So now they're going to change it up on me a little bit, and they want me, they tell me that the sample mean is 34. Okay, so the sample mean is 34, and they want me to find, what do they want me to find? Using the minimum sample size that we already found. So we're going to use N equals 56. Does it seem likely that the population mean could be within 3% of the sample mean? Okay, so let's go ahead and find E. So our margin of error E here, we're going to go ahead and take our critical value for 95%, that's 1.96. We're going to take our standard deviation, and this time we're going to adjust using the square root of 56. 56 came from part A, and that gives us an E of 0.804. So I think we have all the information now to do the work. We've got the sample mean, we have the sample size, we have the margin of error, and so I think we're going to be able to answer this question. So let's go to the next page. So I went back to drawing a picture. I always like to draw a picture. I like to see what's going on. So I put my sample mean in the middle. They told me that was 34. And then on the left side, I subtracted 0.804. That's what we found to be the margin of error. That was E. And then on the other side, I added 0.804, the margin of error. So now I know my confidence interval, right? I'm going to go from the 33.196 all the way up to 34.804. And so I am 95% confident that my population mean is going to lie somewhere between the 33.196 and the 34.804. But they asked me to look at that a little bit different. So let me box what I've got here. This is a never-ending problem here. They wanted to know if the population mean was within 3% of the sample mean, would it still be likely? And so what we're going to do is we're going to take 3% of the sample mean, that's 1.02. We're going to add that back to the sample mean. In other words, if we take the sample mean plus another 3%, we would get here to 35.02. Well, let's take a look. Does 35.02 lie inside my confidence interval? No, it's over here, right? It is right here. And so it's outside of my confidence interval. Because it's outside of my confidence interval, it is not likely that that's where the population mean would lie. So then they want me to do the same thing if it's 0.3%. So if I take the sample mean and I add 0.3% to it, I'm sitting here at 34.102. Well, that one works. That one is inside of the confidence interval, right? It's actually just to the right here of the mean. And so since it is, then it is likely because we're 95% confident that the population mean is going to lie inside of that confidence interval. So if the population mean ends up being 34.102, then I'm good to go because it's inside that confidence interval.